All right, so this is a basic introduction to the last chapter, derivatives. All right, the first part is just finding the average rate of change. The average rate of change is the same thing as the changes over in y over the changes in x. All right, or simply put, you guys already know y2 minus y1, x2 minus x1, right? And this is your basic formula for slope or gradient, as they call it. All right. It's a very, very simple section. If I were to look at this graph and I were to ask you guys what is the average rate of change from 1 to 3, all we have to do is find the slope of that, right? So first off, 3 goes to 9 and 1 goes to 5, right? So all we got to do is take the slope of this. So 5 minus 9, 1 minus 3, that's the same thing as negative 4 over negative 2, which is just 2. So the average rate of change from 1 to 3 is going to be 2. Let's look at the average rate of change from x equals 1 to x equals 4. So again, 1 we're going to get 5, right? And then x for x equals 4, we're going to get 5 as well. So if we were to find the average rate of change of this, it's 5 minus 5 over 4 minus 1, and that's going to be 0 over 3, which is just 0. So the average rate of change is from here to here is actually 0, and the reason why is because there is a horizontal line. All right? So looking at a graph, you can basically find the slope and find the average rate of change, and that's not that hard, all right? But you can also do this with a table, right? So in this example, which I copied from a book, the table shows the number of bacteria, N, present in the enclosed environment. Find the average growth rate of the population size over the first 4 hours. So over the first 4 hours, right? So that means we're using this chart here over the first 4 hours. That means 0, 1, 2, 3, and 4. So don't forget the 0. Count that. So if we're looking at the first 4 hours, we're looking at the average growth rate. We're looking at the slope. We're finding the slope, right? So we have 4 goes to 62. And I'm just going to write it as points because it's a lot easier to plug it in. And 0 goes to 30. So if we were to find the average rate of change, we have y2 minus y1. So 62 minus 30, 4 minus 0. So this is going to be 32 over 4, which is 8. So the average growth rate, of the population over the first 4 hours is 8, right? And we can do this with other charts as well, as in, like, instead of time, we're going to use like hours. So please be careful when you guys read that kind of stuff, right? And the next essential thing that we need to cover is derivatives. And some of you guys have seen it, some of you guys have heard it, but let's go over the very basic rules of derivatives, all right? So, and I'll tell you why we need derivatives in the next video. For now, we just need to know how to do it. The first rule is if f of x, and this is like the same thing as y, all right? If f of x equals a constant, then the derivative of f of x equals 0. So for instance, if f of x equaled 5, then your derivative, and that little symbol right here, this little notation is your derivative, equals 0. Doesn't matter what number it is, it's going to equal 0. It's almost like the same thing as like when you have a to the 0 power, that's always going to be 1. So it's the same kind of concept. Like any number you find a derivative of it, it's going to be 0. All right? Here, this is your power rule right here. So here, if f of x equals x to the nth power, then your derivative equals n times x to the n minus n or minus 1 power. So kind of confusing. Let me show you an example. F of x equals, let's say, x to the third, right? So that means our derivative of f of x is, so what what this power rule does is it takes this power, brings it to the front. So we have 3x, right? Now you take it and you subtract 1, so 3 minus 1 is 2. Alright, so hopefully you guys saw that. This is called the power rule, and this is the very basic rule of derivatives. Alright, let's look at another example. Here we have f of x equals a times x raised to the nth power. Then our derivative is a times n times x raised to the n minus 1 power. So again, doesn't look real pretty right there, but using an example, let's see this. So let's say we have 2x to the, let's say, 5th. Alright? So again, our power rule tells you that if you want to take the derivative, you take this power, you put it down to the front. So we have f of x. Take it down to the front, so we have 5 times 2, right? Then x. Alright, so 5 times 2, then x. Then we take 5 and we minus 1, so that becomes a 4. To simplify this, we have 10x to the 4th. Alright, so that's the very basic power rule. Here we're adding two different functions. Alright, so if f of x equaled, let's say, 2x, alright, so 2x plus, let's say, 3x to the third, we want to find a derivative. So what we do is we take each one, we derive it first, and then if we can add it, combine it, then we'll combine it. But take one at a time. So the first one, here we have a exponent of 1, right? So if we want to take the derivative, we take this exponent of 1, we multiply it to the front, so 1 times 2, right? And then x, and then we take that 1 and subtract it with 1 again, so that's a 0. So if we're to simplify this, 1 times 2 is 2, x to the 0 power is just 1, so it's actually just 2, alright? 3x, so here we take the 3, we multiply it to the front, so 3 times 3. We still have x. Then we take 3, we subtract 1, that becomes a 2. So if we were to simplify this, we have 9x squared. Alright? Man, just thinking about it, it sounds confusing, but once you start practicing it, it's fairly easy. Alright, so let's look at an example. Here we have f of x equals x to the 4th, and we want to find derivatives of all of these, right? So again, we have x to the 4th. Maybe I should write it a little bigger. So x to the 4th, all we got to do is take this, put it to the front. Alright, so we have 4x. Then we take this and we subtract 1, so we have 3. So this is the same thing as our derivative, and that's it. That's our answer. Alright, B. We have f of x equals 3x to the 5th. Again, we want to find the derivative. So we take this 5, we multiply it to the front number, so 5 times 3 is 15, x, then 5 minus 1 is just 4, and that's it. Alright? C, f of x equals 7. So remember that first rule, the derivative of any constant is going to be 0. Simple as that. So for this one, we have f of x equals 1 over x. I can show you guys the quotient rule and then the product rule and all that stuff, but it just gets confusing because they're not really going to give you guys, I guess, like a hard equation like that. So I'm going to show you guys the longer way of this. 1 over x is technically the same thing as x to the negative first power. Alright? So we're trying to find a derivative of this. If we want to find the derivative of that, we take that exponent, which is negative 1, and we multiply it to the first part, or the number in front, which is 1, right? So 1 times negative 1 is negative 1, x. Negative 1 minus 1 is negative 2, so this is going to be x to the negative 2. But we don't really write terms with negative exponents, so that actually goes to the bottom. This derivative is actually negative 1 over x to the square, or x squared. Alright? Last problem, we have f of x equals 3x squared minus 2x plus 1 over x squared. So all I'm going to do is find a derivative, but do it one by one. Alright? So this equals this one first. So we take the 2, we multiply it to the front number, that's a 6x. 2 minus 1 is just 1. We don't have to write that, but I'm going to write that just to show you. Alright, so minus 2x to the first power, right? So 1 times 2 is just 2. X, then 1 minus 1, which is 0. So this is x to the 0, but we all know that x to the 0 is just 1, so let's just get rid of it. And then the last one, we have plus, this is actually x to the negative 2, right? So we take this negative 2, we multiply it to the 1 in front, so it's negative 2 x. Negative 2 minus 1 is negative 3, so this is negative 3. But we know that we can't have negative exponents, so this is negative 2 all over x to the third. So if we were to write this into our equation, this is going to be negative 2x to the third. So this right here is our derivative of that. Alright? So in class, we're going to work on derivatives. We're going to work on finding the average rate of change, just to practice for the more complicated things in calculus in the next videos, in the next video and the video after that. All right. So please watch it, take note. If you have a question, write it down. That's it.